All right, let's talk about hypermedia without all the hype. I think sometimes when this topic comes up, it can get confusing with all the different acronyms and the different formats, and sometimes leave people with this idea that the goal of hypermedia is to be able to point a generic API client at an API, and it just somehow, through hypermedia magic, understands the entire API and how to do whatever needs to be done. And that's not the goal of hypermedia. In fact, similar techniques can be accomplished with technology that predates REST, at least in popularity. But hypermedia, if we're going to boil it down to its essential, to the simple, hypermedia is just saying the shared context, the information that both the API creator and the consumer have to understand, that shared understanding between those two parties, is simply the format of the response, the document, the resource, the thing you're going to get back from the API. That's the only thing that both parties need to understand. That's the shared understanding that needs to happen between the API creator and consumer. And really, that's the thing then that needs to be documented. So as long as I understand the shape of the resource I'm going to get back from the API, I know where to go next or how to find whatever else I need, because I understand it's going to be in that document. I don't construct URLs, I traverse URLs. And that, in a nutshell, is hypermedia without the hype. That's the talk. But we've got a lot more time, so we might as well delve a little bit deeper into it all. And before we do that, it's probably useful to get a little context about the different types of APIs and how they work. And that'll help us understand a little bit more the usefulness of hypermedia. Generally speaking, APIs get put into two different buckets. There's RPC APIs and there's HTTP APIs. Now, people may refer to HTTP APIs or web APIs as different things, but these really are the two buckets that they tend to be boiled down to. So let's take a look at both of those. First of all, we have an RPC style API. An RPC API is just running some type of method. It's a remote procedure call, right? It's running a function or a method just remotely. It's the same as making a call to a function you wrote in your code. It just happens to be a call that's on somebody else's server. It's on somebody else's computer, and you're using something to do that remotely. So really, RPC doesn't care much about the fact that you're using HTTP. For it, it's just a pipe. It's just the way that the call is transmitted to the remote server. It could use something else, and in fact, a lot of RPC APIs do use something other than HTTP. But in the case of an HTTP or a HTTP protocol API that's RPC, the things that need to be shared between the client and the creator, between the consumer of the API and the API itself, are really the objects, the methods, and the arguments, the responses you get back from the API, and then, well, what function am I going to call remotely, and what arguments am I going to pass it? And now those methods and those arguments, maybe they're different URLs, maybe they're the same URL. Maybe the method is a query param, and all of the arguments for the method are in the body of a post. It doesn't really matter with RPC because, again, RPC treats HTTP as just an implementation detail. How did the call get to me, and how am I going to ship back the output of my method back to the client? But we can see here for an RPC, it's primarily method focused. It's focused on, well, you're calling a function, and from a documentation and a communication standpoint, the thing that we need to communicate to those that are using our API is, well, here's the types of objects, the types of responses you're going to get back. Here's the methods you can call, and here's the arguments I expect you to pass to them, and here's kind of how you wrangle that into an HTTP request if I'm exposing my RPC API over HTTP. Now, there's HTTP or web APIs, and I use this as HTTP API. I mean to be an API that is embracing the protocol and embracing aspects of the protocol that are useful in terms of APIs. These are going to be APIs that express the action using the HTTP method. If I want to get something, I make a get call, right? If I want to delete something, I use a delete. If I want to post something, I use post. And if I want to update something, well, if I want to update something, maybe I use post, maybe I use put, maybe I use patch. And that's a whole nother talk on how to use HTTP methods. But an HTTP or a web API is primarily focused on the resource, the thing that you're getting back from the server. And it communicates what you're doing with it by using HTTP and the methods that are built into HTTP. It also communicates whether you were successful or whether it failed using the HTTP status codes. And the things then in an HTTP or a web API that you have to communicate to the user, that shared understanding that needs to be between the client and the creator of the API, is the resources, so the things that you're going to get back, the things that you're going to work with, and the URLs, because an HTTP or a web API has different endpoints. You'll have an endpoint to say, oh, over here, if say we have a user's resource, you use the user's endpoint. Well, what do you do with the user's endpoint? Well, you would put user and then or users and then the user ID, and that's how you get back a specific user. And over here in another place is the addresses endpoint, and you use a similar technique, right? You take addresses and you add the ID to it, and that would get you back a specific address, or you post to addresses to create an address. But what you have to communicate then to your consumer is not just the things that you're working with, those resources, but also where to get them from, or where to work with them, where those URLs and how to construct those URLs, and how to get to the right part of the API. And honestly, most web APIs are HTTP APIs. They're APIs that embrace the concept of HTTP, but they don't necessarily have hypermedia. Now, when I'm talking about web APIs or HTTP APIs, you may say, well, don't you mean REST APIs? That certainly sounds like what you're describing is a RESTful API. Well, it's not, honestly. You can embrace the ideas of HTTP status code and HTTP methods and still not be a RESTful API. To be a RESTful API, you have to introduce the concept of hypermedia. And hypermedia just says the only thing that I need to share between the API creator and the API consumer is the shape of the resource. It's just the thing that you're going to get back from the API, the thing that you're going to work from. Because once you know the shape of that, well, you'll be able to get wherever you need to go. And the concept may be kind of hard to keep in mind, but there's a really great example that I think probably everybody understands and has used and is familiar with. And that's that one of the best, most widely used RESTful APIs is RSS. Yeah, any RSS feed is an API. And the big difference between an HTTP API, where you have a bunch of endpoints, and a REST API is that you have a single entry point with a REST API. You don't need to communicate a bunch of URLs and what resources they lead to with a REST API. You have a singular entry point, and you say, well, that's how you get into this API. Well, think of an RSS feed. You have a single entry point. You have the feed. And anything you need to do then, you do based on the response you get from that RSS feed. That RSS feed tells you where the post is. Or if it's a podcast, it tells you where the podcast is. Or if people have commented on it, it tells you where to find the comments from. You just traverse the known document, the shared resource. That's the only thing that the server and the client need to understand is, well, what's the RSS format? And once they both understand that, the client can traverse it without having to worry about, well, how do I construct this URL? In fact, what's great about RSS is you may get the feed from one server and you may jump to another server to get the actual content. So when we think about, well, what's a practical example of a hypermedia API, of a REST API? Just think about how RSS works and how the only thing that really a client needs to know is, well, what's the RSS format? If I can understand that, I can traverse the API without any problem. Now that we've covered context, let's consider an example. A lot of times when I give talks, I'll tell people to go rate my talk on Joined-In. And when I say that, they don't somehow try to construct the URL to get to my talk. No, they just go to Joined In. They go to the website. And what do they see? Do they see my talk? They don't see my talk. They see a list of conferences. But they understand that because they understand that Joined In is a site about conferences. That's the shared understanding between them and Joined In. They understand the context of the document, the thing that they're getting back. And they say, oh, here's a list of conferences. Oh, there's the conference that I was at that Tim gave his talk at. So I'm going to do what? I'm going to try to figure out how to get to that conference's page. I'm going to figure out how to go to a URL that has that information. No, they're not. They're just going to click the link to that conference because that's how the web works. And when they go to that conference, they're going to see a list of talks. And they're going to traverse that list. They're going to find the talk that I gave. And again, they're just going to click a link. And that's going to go to my talks page. And then they're going to rate my talk. Because that's the way the web works. And applying that to our APIs is what Hypermedia is all about. Here's another example. Imagine Amazon. When you went to see a product on Amazon, you were told that you had to go to /products and the product ID to be able to get all the product information. No, you just follow the link. But that's exactly what this is when we build APIs like this. So let's take a look at this example API. You can see we have pets, we have users, and we have addresses. So we have, let's take a look at the user resource first. We have a user, name is Bob Tables, got his email address, and then we have an address here. And maybe if we had formatted this API differently, maybe it would be address_ID to indicate, hey, this is an ID of an address. But we see we have an address. Now, we would then have to know what to do with that ID if I wanted to get more information about the address. So not only would I have to communicate in my documentation that, hey, this is the shape of the user's resource. There's going to be a name and email and an address ID. I'd also have to communicate, if you want information about that address, you have to look at the addresses endpoint. And, well, how do you get to the address, the specific address? Well, you can concatenate the ID to the address base URL, and then you'll have a URL to get the address, and then you make that request, and look what we'll get. We'll get the person's address. 123 Main Street. There's a city. There's a state. Having the client construct the URL, it's a little dangerous, right? Just a typo here or forgetting to add the slash, you create a lot of problems where the user's not sure why they're getting a 404 and you're not sure why they're getting a 404 either because the data they're looking for is definitely there. You don't realize it's just because someone typoed something when they were constructing the URL. The other thing is we have two pets here, right? There's Odie and there's Garfield, and they each have their own resource. They're under the pets API endpoint, and they both have a reference to the owner. So if we were at a pet and we see that they have an owner ID, we would be able to traverse to the owner from the pet by simply taking users / and appending the owner ID after users, and we can say, okay, we can find out that if we know about Odie, we can create the URL to his owner, and we can find that, well, it's Bob Tables that owns Odie. But there's no way, at least from looking at these responses, there's no way to understand how you would go from the user to the pet. That would also have to be something that was documented, that was communicated, that was a shared understanding between the API creator and the API consumer. We'd have to know, well, given a user, this is how you find the pets. Because just from the shape of this data, we have no idea how to do that. Let's take a look at this same API, only we'll add Hypermedia to it. So here's the same API with Hypermedia. You'll see still users / the user ID. We still have a name, we still have an email. What we don't anymore have is the address as an ID that's a property of this resource. We do have, though, this _links section. Now, I'm borrowing the HAL-JSON spec, and there's a bunch of different Hypermedia specs out there. HAL-JSON tends to be one of the simplest, most straightforward, easy to implement, and I would say open to be able to kind of add your own shapes and add your own concepts to it. So that's why I use it as an example. It's also what I would tend to use if I was building an API. Hal says there's one thing you have to have, and it's underscore links. So every resource has to have this links object, and you have to have a self link. And you can see here, the self link is really just the href, the link to the resource that I'm at. So we see it's /users, and then it's the user ID. Now, each of these links doesn't have to be just a single link. It could be an array of links. And we know what kind of link it is really from the key. So if we look at the links object, the self key tells us this is the link to me, the resource that you're at. The address link tells you, well, this is the link to the address. And now all of a sudden, our users, our consumers, don't have to construct this URL to addresses. They can just traverse it. They know, if they understand the shape of the user's response, they know how to go from a user to an address. What do? You just follow the links and the address link. Follow that, and you'll get the user's address. But what we also see here is now all of a sudden, we are able to determine how to find out the pets that this user owns, because the URL is right there. You want to know what pets this user owns? Well, go to /pets and then use the user as a filter. Another thing you might notice here, and we'll talk about this probably a little bit more, is the fact that we're not using the user ID as the filter. What we're really using is the user's URL, because a URL is a URI. It's an ID by itself. We can just pass it around like it's an ID, and then our client doesn't have to worry about our internal IDs. It just has to worry about what it cares about, which is the URL to get the resource with, or to work with the resource if they're not getting it, if they're manipulating it. Not only can Hypermedia help you avoid the client having to construct URLs, it can also help you avoid having the client make more requests than are needed, because Hypermedia supports this notion of embedding other resources. So here, not only am I getting the user back, but I'm also saying I don't want to traverse the links to get the address. I would like the address to be embedded back in my response. So now our response not only has an underscore links, but it also has an underscore embedded. And those two keys, underscore link and underscore embedded, are the only two keys that the HAL spec says or defines anything for. And the links, I know what thing I'm going to get back based off the key of the link. So in this case, address tells me I'm going to get back an address resources. The same thing is true about underscore embedded. The key address tells me, well, what does this contain? Well, here it contains an address. It contains this address resource. And if I know what an address resource should look like, I know exactly what I'm going to find here. Because again, the thing that is shared between the creator of the API and the consumer of the API is the shape of these resources. It's the structure, the document. That's the only thing that really needs to be shared. It's the only thing that needs to be documented, because if I would have followed the link to the address, I know what to get back. If I say I want it embedded, I know what I'm going to get. It's going to be an address, and we can see here it has the street address, has the city, has the state, and now maybe the reason why Hal says underscore links self is the only thing, that's the only key that is required, because I may get back this resource without specifically requesting it, right? I may get it back as an embedded resource. So for sure, I want to know the URL of that resource, because what if I want to do something with it? What if I want to delete the address? Well, I have the link there. I may not have actually been asking for that specific resource. That resource may have come back to me as an embedded resource, but because the self link is always going to be on a resource, at least a HAL resource, I know I can always know where to find it and how to work with it, because I would just use that link. I would just follow that link. If I wanted to delete this address, I'd make a delete request to it. If I wanted to update it, I'd maybe make a post or a put. If I wanted to get it by itself, I'd fetch it with a get. And if I wanted to cache it too, I'd probably start using these self links as the cache key on my client. I don't have to worry about collision then, because as you can see, we don't have IDs. We're not giving our client different IDs to keep track of. We're giving them URLs. We're giving them something they can actually use to find and work with these resources. And because they're all unique, there's not going to be any collisions if I'm trying to cache them someplace and keep that data local. In fact, because they're all URLs and because they're all unique, I can probably leverage some normal HTTP caching utilities for some of this stuff if I want to cache these responses. So we can see not only does it make does Hypermedia make it so your client doesn't have to create or construct those URLs. It can also make it so your client doesn't have to make a lot of requests because it can embed resources inside of other resources. And the truth is, you look at this and you say, well, how would I use, embedded resources? Maybe my API is simple and I don't really need to give my client the ability to ask for related resources to be included. Well, the truth is, if you really have any API and you have a collection of things, you're probably going to want to be embedding those resources. Why? Well, because collections are resources too. Because really, what's a collection? A collection represents a set of items, right? A collection is really a resource because collections have properties. Here we can see this is the pets collection for a specific user. And again, we can see we're not filtering by user ID, we're filtering by the user's URL, because as far as the client is concerned, as far as the consumer of our API cares, that's the thing that represents the user. And we can see here the properties of our collection resource are the count. How many pets have I returned? And it's really the total too. How many pets in total do I have? And in this case, we can see, well, I've returned 2 pets and I have 2 pets. So I've got all of the results. We still have an underscore links here because this is just another resource. It happens to be a collection resource, but it's just another resource. It has a self link. And you can see that's the link, obviously, that we're at. It also has a first and a last link. So this is hinting at the idea that links in the context of a collection will help us traverse the collection. Now, if I had a very different perspective on life, and instead of 2 pets, I had, say, 22 pets, well, then maybe all my pets wouldn't show on a single page of the collection. And now instead of my self, first, and last URLs being exactly the same, I might have a next now to tell me I can get to my next page. And that's really, really important because a lot of times APIs expect the consumer to figure out how to page. And that can be confusing because there's a lot of shared knowledge then. Is 0 the first page or is 1 the first page? How do I get to the next page and make sure I'm not somehow overlapping items, especially in a collection that, say, may change as I'm traversing it? And that can get a little confusing. And that can lead to a lot of issues with the client and the consumer code not calculating the collection correctly and leading to a lot of confusion. But with a Hypermedia API, I don't have to worry about that because my client doesn't know how to construct URLs. My client has to follow the URLs that are in the response. The only thing that we both understand, the only shared understanding, the only documentation is the response. And the response says, hey, if you get the pets collection and you want to go to the next page, well, follow the next link. That's where you're going to get to it. And that's great because now not only does my client not have to construct the URL, but if I want to change how paging is done in my API, it's not a breaking change because I've not told the client it's their responsibility to figure that out. In fact, I've told the client it's my responsibility and all I want you to do is follow the link. So say we have a collection that we thought was pretty static, so we paged it in what might be considered a normal paging perspective where it's page 1 or we have like a limit and we say what the offset is, but then we realize no, this collection changes rapidly and it changes a lot of times when people are traversing it. So if we're just saying skip the first 50 to give me the the 51st and on for like the next 10, so if I'm on the 5th page, I say go to the 51st thing and give me the next 10. Well, if I'm adding to that collection in real time, all of a sudden that starts shifting and records that were at the end of my last page are now at the top of my next page, and that's going to confuse my user. And we say, well, that's not how it needs to work. Really what we want to say is the last page that I got, give me the items that come right after that item. Well, that's if we're having our consumers, our clients of our API, construct those paging URLs, Changing that is a breaking change for everybody because we're breaking the way that their code is going to work. But if we told our clients, don't try to figure it out yourself, instead just follow the links that I give you, we can go from a more statically paged concept to a more cursor type paging concept without breaking anything, because all I have to do is follow the links. So this is a collection. We have our collection resource data, the properties and the links that help us page your collection. But then we also have the collection data. So here we have embedded pets. So here's the 2 pets that I own. And you can see, just like links, the embedded section has these keys that tell us the type of thing that I'm going to find. So in this case, I'm expecting I'm going to find pet resources here because this is my pets. But it doesn't have to be just a singular resource. In this case, I'm giving back an array of pets. And you can see the pets structure is the same as we'd expect. There's links with a self link. There's also a link back to the user. We see then the properties of this resource. That we have a cat that's named Garfield and a dog that's named Odie. What might be interesting to look at in the link for the user link is the fact that we do more than an href. In fact, there's a couple extra parameters that can be used in links. And here we're using the title to help shortcut the fact that a lot of times we may want to show, or you want to traverse to the user, but we may want on the client side, and however this is rendered to the person who is using this application, they may want to not just say, show me the user data, show me more information about the owner. They may, in fact, now that I see that, this should probably say owner and not user. But they may want to see the user's name. So I can add that to the link and say, hey, here's a human-friendly way to show what this thing that you would traverse to if you wanted to get more information about this resource. Here's a human-friendly way to describe that to whoever the end user is. So instead of just some type of button or something that says, oh, take me to the owner, now we can say, hey, there's a button that says take me to Bob Tables, because we've put that into the link and we've given a little bit more context about the link. And this can be much more useful if, say, for some reason a pet could be owned by multiple owners, right? And then maybe I'd have an array in this link, and user would no longer be singular, but it would be an array. And then for sure the title would be useful because it would help the end user know, well, which user am I going to look at? I can see that this pet is owned by more than one. I want information on the owners, but I don't know, just based off of the URI, who they are, so I don't know who I want to traverse to. So giving something like a title to the link can help the end user understand, well, which, in the context, in the case when it's an array of links, which one I want to traverse to. Or as it's done here, it's just something that we think the client is going to want to display. So instead of saying you have to fetch the whole thing just to give the name, well, let's give the title and the link. So you have that frequently used data just right there, ready to be used. So let's take a look at the entry point for our API. We hit slash and we get just a set of links. Now, there's really nothing that says a resource has to have properties of its own. It certainly could, but in this case, it's just a set of links. In fact, let's go back to our collection for a second and just consider the fact that the collection itself wouldn't necessarily have to have embedded. If we wanted a much lighter collection, instead of embedded, we could give links to all the pets. And maybe just use the title of the link to give you the pet name, so you can get a very lightweight collection back without having to get all of the data for all of the pets. So if you're dealing with a very large collection, or if you're dealing with resources that are significant, you may want to have your collection not embed those resources, but actually just have a set of links that lets your client decide what it wants to traverse and when. Now let's go back to our entry point. You'll see that we have some links here. There's the self link, again, as always, which just says, hey, this is the URL you just requested. And we tell our clients how to find the users. Again, it looks at users and it says, I know what that is. That is a collection of users. It looks at pets and says, I know what that is. That's the pets collection resource. And I know that if I traverse there, I know what shape, I know what type of object I'm going to get back, because that is the thing that we have that shared understanding about, the types of the resources our API provides. So in this context, we've documented what a pets collection looks like. So when our API client traverses this entry point, it says, oh, I want to find pets. So I know I go to this URL. This also means that we've not told our clients what the URL is. So if for some reason we needed to change it, if some reason we needed to point to a different server, we needed to use a different URL, we could change that, and it would be a non-breaking API change, because the only agreement, the only thing that's shared between us is the shape of those resources. Also notice that we have an interesting owned link. Now this owned link is a templated link, and there's a spec that says what a templated link and how to expand those templates is. In this case, the question mark user just says this is expecting a query param called user, and so if you give it the user URI, the ID of the user, right, you'll get the pets that user owns. And we've already seen what that collection would look like. But this is how we would express it without having to traverse to the user first. This is how we would express it at the root of our API. So if for some reason the client already had the user's URI because it had cached that response in the past and it just wanted to know the pets, it could take the information it had cached locally and use it to construct this URL. I say construct this URL. This is the only time when the client's doing the construction, but it's doing that construction based off of a known format, a known template. The URL, the href, is what they don't need to know about. They just need to know, oh, I take this templated URL and I just insert the data where it belongs in the template. So that's the only place where a client's going to have to do some type of URL construction. But the truth is, probably whatever language, whatever platform, whatever framework the consumer of your API is using, there's a library that takes these templated URLs, and you can just give it the variable and it'll construct it for you. So this is what the entry point for a Hypermedia API would look like. It would have the links that you would need to traverse to do whatever you need to do, defined right here in the entry point. All right, let's take a look at one more thing. It's kind of a bonus. Let's talk about errors for a second. When you're talking about HTTP APIs, any type of API that leverages HTTP, one complaint sometimes you'll hear is that the HTTP statuses just aren't enough. The reason why we have to invent our own status codes is because you have no idea how many errors my API can have, way more than there are HTTP status codes for. Well, the truth is, the HTTP status codes are there to give you the general concept of the error, what it is generally, and there's nothing saying you can't push back a body that describes what went wrong with your application. And there exists an HTTP problem detail spec that lists a couple parameters that you can use to make errors more understandable. Now, it allows you to set whatever custom data you want. In this way, in this example, you can see we have some custom data. We say the invalid parameters are the age and the color, and because you didn't give me a positive integer, I don't know what a negative age would be, right? And you didn't give me, I guess, the user's favorite color or something. You missed some parameters. But what the HTTP problem spec defines is this type and title and a couple other properties that you can use in your error. The title is the human-friendly thing, the thing that you might display to a person and say, hey, this is what went wrong. In this case, obviously, you sent some request parameters that weren't valid. They didn't validate. But the type is what's really interesting, because the problem detail spec says the type is what should be used as kind of the ID of the error. If you're going to get this type of error, this is the thing that you would use to reference that. And in a lot of cases, in a lot of code, this is something that we would use an error code for. Maybe a bunch of numbers, which computers are fine with, but make it really difficult for people, right? HTTP problem spec says this type needs to be a URL. And it needs to be a URL that when you dereference it, when you follow that link, you know what you find? You find information about that error. So not only in a Hypermedia API, not only can we leverage links to make our API a lot easier on our clients, they don't have to construct URLs. They can embed data and they can embed resources, but we can also use the concepts of Hypermedia in our errors to make our errors better too, and say, hey, we're going to allow you to kind of traverse to the solution from the error itself. So instead of an error code, we can just provide yet another link to make it really easy for our consumers to figure out what's going on, because hey, links are how the web works. So why not use them here too? So that's it. Hypermedia without the hype. I hope this has been a useful talk for you. If you want to know more, you can find me online. I'm at TJ Lytle at Twitter. So just mention me there if you have some questions or any feedback on this. And I'd love to help you if I can.